The radius of the wheel is always greater than that of the axle. Devices that use principle of wheel and axle are screwdriver, wheel spanner, gear wheel, and windmill. The aim of this experiment is to determine mechanical advantage, velocity ratio, and efficiency of a wheel and axle. Requirements: a ruler, wheel and axle, a load, and a spring balance. Set up the apparatus as shown in the diagram. Then measure the radius of the wheel and axle by using a ruler. The radius of a wheel is 15 centimeters. Measure the radius of the axle. The radius of the axle is 5 centimeters. Then hang a mass of 500 grams around a string wound around the axle. Then pull a string wound around a wheel until it makes one complete rotation. This is one complete rotation. Then find the distance moved by effort and the distance moved by load. The distance moved by effort, this will be one complete rotation, and this will be given by 2 pi capital R. And the distance moved by load, this will be given by 2 pi R. Next, take a spring balance and tie on a spring that is wound around the wheel. Apply the effort and then record the effort. The effort applied, this is 270 gram force, and the load, this was 500 gram force. Velocity ratio, this is the distance moved by effort over the distance moved by a load. So velocity ratio, this is the distance moved by effort over the distance moved by load. The distance moved by effort, that is 2 pi capital R, and the distance moved by load, this will be 2 pi R. This will give you a ratio of capital R over R. Mechanical advantage, this is a ratio of load over effort. Mechanical advantage is a ratio of load over effort. From the data, the load, this is 500 gram force, and the effort, this was 270 gram force, and this will give you the value of 1.85. And from velocity ratio, capital R over R, this gives you the value of 15 centimeter over 5 centimeter, which is equal to 3. So velocity ratio is 3 and mechanical advantage is 1.85. The efficiency of a machine, this is a ratio of mechanical advantage over velocity ratio, then times 100%. So efficiency, this equals to mechanical advantage over velocity ratio, then times 100%. Mechanical advantage is 1.85 and velocity ratio is 3. Efficiency of a machine is a ratio of mechanical advantage over velocity ratio times 100. This is 185 divided by 3 times 100%. Efficiency is equal to 61.67%. So this is the efficiency of this wheel and axle. According to this experiment, since the radius of the wheel is greater than that of the axle, the velocity ratio will always be greater than 1. Now, how can this principle of this experiment be utilized in our life? The aim of this experiment to determine mechanical advantage, velocity ratio, and efficiency of inclined plane. Requirements: a meter rule, spring balance, smooth block, inclined plane, and a thread. Procedure: measure the weight of the block using a spring balance and record the measurement. From the spring balance, the measured value, that is 265 gram force. Measure the distance of inclined plane using a ruler. And then record. The distance of inclined plane, that is 47 17.5 centimeter. Then measure the height of inclined plane. This is 17.5 centimeter. Pull a block up the inclined plane using a spring balance and then record the effort applied. From the reading, spring balance reading, the effort applied, this is 125 gram force. Mechanical advantage, this is the ratio of load over effort. From our experiment, the load, this is 265 gram force, and the effort, this is 125 gram force. Velocity ratio, this is the distance moved by effort over the distance moved by load. The distance moved by effort is this length, that is D, and the distance moved by load is the height of the inclined plane, that is H. The distance moved by effort, the length of inclined plane. From the experiment, the length of inclined plane, that is 47.5 centimeter, and the distance moved by load, that is H. From this data, that is 17.5 centimeter. This ratio will give you 2.71. So we have mechanical advantage has 2.12 and velocity ratio is 2.71. Efficiency of a machine. This is the ratio of mechanical advantage over velocity ratio, and normally this ratio is expressed in percentage. So using the data, we have obtained efficiency of a machine that will be 2.12 divided by 2.71 times 100%. And this will give you 78.23%. So you can say the efficiency of this machine, inclined plane, this is 78.23. Based on this experiment, what misconceptions do you think students had?
Plane mirrors are used as a looking glasses. When light rays are incident normally on the mirror, they reflect a straight back. Aim of the experiment: to locate an image formed by a plane mirror. Requirements: plane mirror, ruler, optical pins, white paper, and a soft board. Precaution: use thin miller in this experiment so as to avoid multiple images. Procedure: draw a line L 15 cm length in the middle of the plain sheet of a paper and mark it as line LL. Measure a 4 cm line perpendicular to the line LL. Place the miller upright with reflecting surface on the line L. Place a search pin at the extreme end of the line at point O. Place 2 search pins QP to fall in line with the image when viewed at a bench level. Repeat with 2 other pins SR. Mark the pin's position and draw a straight line through QP and extend it behind the miller. And draw the second line through SR, also extend it behind the miller. Ensure the 2 lines intersect one another, and at the point of intersection, mark it as I. Measure the perpendicular distance OL and the LI. From the observation, OL is equal to 4 centimeters. And also LI is equal to 4 centimeters. It was observed that the distance OL is equal to the distance IL. When an object is present in front of a plane miller, the image will be as far as the distance of the object. In plane millers, the distance of the image is equal to the distance of the objective from the miller. Source of errors: parallax in viewing the pins. Question: explain the uses of plane miller in daily life.
An electric circuit is a continuous path taken by electron to flow when electrical devices are connected. The aim of this experiment is to verify Ohm's law. Requirements: an ammeter, voltmeter, resistor, rheostat, a key, 2 cells, and connecting wires. Precaution: ensure the temperature of the wire kept constant throughout the experiment. by opening the key in each reading. Use small current procedure. Connect the device as shown in the circuit diagram on the board. Connect positive terminal for cell to the positive terminal of ammeter. Then from negative terminal of an ammeter, because this is a series connection with the battery, to a resistor, which is our conductor, whereby this resistor is connected in parallel with a voltmeter. And because from ammeter the terminal negative is from ammeter, it means that in the part of voltmeter we are supposed to connect in the positive terminal. Then from negative terminal of voltmeter supposed to be connected in parallel with a resistor, which is our conductor. Then we connect direct to the rheostat. From rheostat, the switch. From the key to the negative part of the cell. Now the circuit is complete. Then close the switch. Then observe what's happening in an ammeter and in a voltmeter. It means that the current is flowing. Then adjust the rheostat and read the voltmeter and ammeter. The voltmeter reading is 1 and ammeter reading is 0.6. And remove the switch. Repeat the same procedure by changing the position of slide in order to obtain 4 reading. Voltmeter reading is 1 volt and ammeter reading is 0.6. Repeat the procedure by changing the position of slides in order to obtain 4 more readings. After obtaining the reading, use the reading from the table to draw a graph by following a proper scale. The nature of graph is the graph of voltage against current. And when you observe in the graph, it seems that when the value of voltage is increasing, at the same time the value of current is increasing. This verifies that voltage is directly proportional to the current. This verifies the Ohm's law, which states that the current flowing through a conductor is directly proportional to the potential difference across the conductor, provided that the physical state of a conductor remain constant.
Forces that gives rise to turning effect are very common to everyday situation. When a door is turned to open or to close, or when a key is turned to lock or to unlock, turning force is applied. This turning force is called the moment of force. The moment of force is the product of a force and the perpendicular distance from the pivot or fulcrum. The aim of this experiment is to investigate conditions required to make a system to be in equilibrium. Requirements: ruler, mass hangers, masses, knife edge, and rectangular block. Arrange the devices as per the diagram. Place the rectangular block on a proper position and place the knife edge on it. Balance the metal rule using knife edge and record the balance point. The balance point is at 50 centimeters mark. Therefore, G is equal to 50. By using thin thread or thin wire, suspend the masses of 50 and 100 either side and find the balance point. Find the balance point by adjusting the distance from 50 mass attached to the center of the metal rule either side. The distance from the center to mass of 50 grams is 24 centimeters, while the distance from 100 grams it is 12 centimeters. Now record these findings in the table. M1 is 50 grams, M2 is 100 grams, distance 1, 24 centimeters, distance 2 is 12 centimeters. Now let's find the moment due to 50 grams and the moment due to 100 grams, which is 50 gram force times distance which is 24. That gives you 1,200 gram force centimeter. And the other part is 100 grams force times 12 centimeters, which gives you 1,200 grams force centimeter. Now repeat step 2 and 3 by adding 50 grams either side at a time until you get 4 readings by adjusting distance due to mass 1 and distance due to mass 2. From the table, it was observed that the moments of force due to mass 1 when M1 was 50, distance 24 centimeters, is 50 gram force times 24, which gives you 1,200 gram force, and mass 2 was 100 gram force times 12 centimeters, also gives you 1,200 gram force. That means this side balances. As you continue, this value and also this value is the same. Likewise, this value and this value is the same, and this one and this one is the same. Means that total moments in the clockwise are equal to the total moments in the anti-clockwise side. Conclusion. Since the moments of force are equal in either side, therefore, the clockwise moment equals to anti-clockwise moment. This relation is called the principle of moment, which states that when a system is in equilibrium, the total or the sum of clockwise moments is equal to the sum of the anti-clockwise moment about a fulcrum or pivot. Question: where is this principle applied in daily life?
A simple pendulum is a small heavy body all weight suspended by a right inextensible string or thread. If a pendulum is displaced through a small angle and released, it performs a to and fro movements. These to and fro movements is due to the restoring forces caused by gravitational force. The time used by a body to move from one point until it comes back to the same point is called period. The length of a pendulum is the distance from a point of suspension up to the center of gravity of a pendulum bob. The aim of this experiment is to determine the acceleration due to gravity using a simple pendulum. Requirements: pendulum bob, meter rule, thread, wooden pads, stopwatch, and retort stand. Precautions: the readings of length of string should be written with 1 decimal place. This is because the meter rule used as the accuracy of 1 millimeter. Another precaution, average values of time are taken to minimize errors. Procedure. Tie a pendulum bob on a thread. Measure the length of a pendulum bob. Make sure it is approximately 100 centimeters. Hang a pendulum bob on a little stand so that the length is approximately 100 centimeters. Use wooden pads so as to hang it well. With your stopwatch already in hand, now displace a bob to a small angle. Now wait until the motion is steady, then record the time for 20 oscillations. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. For 20 oscillation, the time was 40.1. To minimize the error, repeat the same procedure, record the time, then find the average. Note 1, 2, 14, 15, 16, 17, 18, 19, 20. Again, for 20 oscillation, the time was 39.9 seconds. The average for these two times is 40 seconds. Again, find the period. Now, period is the time for one complete oscillation. So we take the time here, we divide by the number of oscillations. Now the number of oscillations was 20. If you take 40, we divide by 20, we get 2. Now if you square these 2 seconds, you get 4 seconds squared. Repeat the above procedure for values of length 8 centimeter, 60 centimeter, 40 centimeter, and 20 centimeter, and tabulate your results as shown on the table of results. From the table of results, plot a graph of L against periodic time squared. You will get a graph of this nature, which passes through the origin. Now this shows that as L increases, also periodic time squared increases. Then calculate for the slope of the graph. From the graph, the slope is change in L over change in T squared. According to this graph, it is 25 centimeters per second squared. From the graph, the change in L is 50 subtract 25 divided by 2 subtract 1, then you get 25 centimeters per second squared. How to calculate the acceleration due to gravity? Now this is done by relating periodic time and the length of a pendulum, which is given by this equation. Now squaring T squared is equal to 4 pi squared L over G. If you arrange the equation according to a straight line equation, L is equal to G over 4 pi squared times periodic time squared. Now if you relate this equation with the straight line equation, now L will be equal to Y, G over 4 pi squared will be equal to M, which is the slope, and T, periodic time, will be equal to X. And C will be equal to Y-intercept, which is equal to 0 according to this, since the graph passed through the origin. Now, the slope will be equal to G over 4 pi squared. You relate the slope with this equation. Now making G the subject, 4 times pi squared. Now if you substitute the data obtained, you will get 985.96 centimeters per second squared. From this particular experiment, the acceleration due to gravity is 985.96 centimeters per second squared. What challenges have you encountered in this experiment, and how can you minimize them?